Today's video is quite relaxed. I'll explain the issue in a conversational manner. The canopy of a portal frame factory building is a minor component that doesn't attract much attention. However, it often causes headaches for structural engineers, mainly due to the involvement of torsional components. Of course, many structural engineers might not have noticed this issue because the canopy loads are very small, so it never caused a problem. But if the canopy has a large cantilever and the load is not insignificant, it might lead to a failure, which means damage. The destruction is generally caused by the torsion of the cross beam at the base of the canopy. Once this issue is recognized, it appears difficult to solve. The American steel structure specification does include provisions for component torsion, but I didn't fully understand them, and I think they cannot be directly applied here. Structural master Lin Tangjian has always said that specification should be used cautiously, so it's better not to use them. Torsioning components is a deep topic, and I recommend everyone to read Structural Mechanics of Thin-Walled Components by Bao Shiwa and Zhou Jian for a deeper understanding of this issue. However, this is like asking me to dig a well when I just wanted to drink water, and this well is very deep. Is it necessary? I think it is necessary. To do well as an engineer, one must continuously learn and improve oneself. This is the destiny of an engineer. And actually, it's quite interesting. Thinking you're just opening a hole in the ice, you discover straight. I haven't finished reading this book either. I just picked the parts relevant to me, and it was very enlightening. Later, I applied the concepts in a small project. To put it simply, deeper and higher level knowledge gives you a completely different perspective, opposite to what you knew or were sure of before. The so-called mastery empowers boldness. That's the idea. In our era, it's rare for Chinese structural engineers not to have worked on large slab buildings, high-rise shear wall residences. I once put a lot of effort into tuning out a model with the first and second periods as translational and the third as torsional, which left me with the impression that the first period of a building structure must be translational. A few years ago, I got a project with a tower structure where the first period was torsional, and I felt it was unsafe. But at the same time, I felt the architect's plan was mechanically reasonable because I didn't understand and gave up on the project. After reading this book and watching some related videos, I now understand that some structures' first period is indeed torsional. Actually, learning shouldn't be so utilitarian. You should try to broaden your knowledge base. Even if you don't fully understand, at least you've seen it. I used to study mathematics in my free time, and when I came across number theory, I felt that other mathematical knowledge might possibly be useful. However, number theory, especially content related to prime numbers, is definitely not going to be used. So, I felt very fortunate because this stuff stumped geniuses like Gauss, Euler, and Riemann. Euler even said that perhaps God wants to keep some secrets from humanity. If you know a little about these people, calling them geniuses really does them justice. The masters and geniuses we talk about now probably couldn't even hold a candle to those geniuses of their time. The most interesting part is that I actually encountered related problems, mainly doing complex factorization in finite element software, which even Python libraries couldn't solve, and those libraries are already very powerful. Later, I solved it with Mathematica, using a function I had never seen before. After researching it, I found out this function was related to the study of prime numbers. So, if you think basic knowledge is useless, it's just because your research isn't deep enough yet. God asks questions without distinction. Humans play games with division. I know I must have gotten it wrong, because I haven't worked on anything cutting edge. The simplest understanding is that this is a very mature technology. How others have done it cannot be so complicated. It wasn't until later that I realized my approach was wrong from the start. I spent a long time reading related books before I started. Then I forgot all those concepts when it came to actual application. I bought a book written by a top expert and studied it for days, not even sparing the punctuation marks, spending several days on a single page until I finally solved it. That was the most difficult time when I was developing this software. I felt like I couldn't do it. I reflected on why I thought like that. To put it broadly, it actually has to do with the way of thinking given to us by Chinese culture and even the year. So, I think there's no need to deliberately showcase the stuff of our ancestors. Whatever you create, it's hard not to carry national or temporal characteristics. It's something etched in our DNA. I once learned to make architectural plans with a German colleague. Their work was just different from mine. Totally different ideas. I've digressed too much. Back to our topic. Mechanics of thin-walled bar structures. I've placed this book in this location on my website. Everyone interested can refer to it. It's worth mentioning that this book is very comprehensive. To some example calculations are incorrect. Probably because it sells too little. There was no chance to correct them. Of course, specific projects wait for no one. It's impossible to wait until research is complete before producing drawings. Smart structural engineers have figured out many methods to circumvent this problem. Simply using a rope to suspend it seems like making a mountain out of a molehill. A better way is to transform the torsion problem into a bending problem. Sometimes conditions don't allow. My plan was cantilever directly after I referred to the drawings from old engineers. When I first started designing, I despised the act of copying drawings. So now I think it's entirely correct. With more experience, you'll understand. Never start a design from scratch. The same goes for research. It's best to start where others have left off. Let me tell you a story, and you'll understand. An expedition team from Peking University faced danger in the mountains. When they were rescued, they still said, "We did detailed research and planning. That path was supposed to be fine." What they didn't know was that the path had been washed away by a mountain flood. And of course, the locals knew it was the rainy season, and that path was likely to be destroyed. There are too many uncertainties in engineering. When doing complex structures, it's best to consult with engineers who have done similar structures before, or at the very least, study a few sets of drawings about it. An old engineer once told me the crossbeam at the base must be made with a closed section. Now that I've learned the relevant knowledge, I finally understand why. Additionally, it's best to weld the closed section from channel steel. It's not worth it for the construction unit to purchase square steel just for this canopy. Of course, in such simple cases, it can be completely solved with calculation. I recommend using ANSYS for finite element analysis. Make sure to choose the right elements and turn on the warping degrees of freedom. Thin-wall torsion has 7 degrees of freedom, which is key to these theories. And the number of degrees of freedom is the most basic assumption in structural software. Midas only added this function in 2019. SAP 2000 seems not to have specifically addressed this issue. It might have solved it in another way, probably because SAP 2000 has a long history and the program has legacy code issues. ABAQUS should also have implemented it, but I'm not familiar with the specifics. The above is my personal understanding and might be problematic. I welcome everyone to discuss with me. My contact information is already on my website. Also, welcome everyone to visit my website www.qffea.com. That's all for this video. By the way, the background used is a video of the scenery in Xinjiang. I really hope I have the chance to go see it.